Hello, everybody. Today we are working on a solution is a type of mixture notes. Now, what we're trying to get at in this unit is continuing to look at determining if and when a chemical or physical change has occurred and prove that matter is conserved in any reaction. So, this is going to go along with a slideshow that we have here. I just wanted to get you started a little bit, and on the back, there's some that are a little bit tricky that are kind of the wrap up. So, first thing, there's some bell work here. Give this a try. Add it to like somewhere, some blank space on this paper. So in your chart, write and draw what you think each of the following looks like. Is this a single substance or multiple? Like, could you easily separate it? One is milk, one is trail mix. Hopefully you're thinking that milk looks like a single substance and the trail mix looks like you could separate it. Specifically, I love chocolate, so I'm looking at all the M&Ms I'm going to pick out. So then you can go through and add what are two more examples you can think of that looks like that would match up with this. What are some other things that look like a single substance? Maybe think of, are there any beverages? Are there any maybe types of soups? For things you can separate, maybe there's a type of soup that you can separate things. Is there other types of mixes or things that you have that you could separate? So that's kind of just getting us going for today, because our biggest thing by the end of this slides is we want to be able to define and describe the three types of mixtures. There's a solution, a colloid, and a suspension. And bigger than that, we have a homogeneous and a heterogeneous solution. So getting going, there's a number of videos that are kind of in here today. So rather than trying to record me showing you the videos, I just wanted to get you started so you knew what to do and we're set up for success. So continuing here, first, make sure you stop and watch all of the videos in class that are on these slides for today, because they're going to go along with what we're learning about. So video stop number 1 here. What is a mixture? It breaks down in macaroni salad. What are all the different mixtures that are happening there? It's a great start for today. Then there's fill in the blanks here. And when you put this into present mode, it shows them up one at a time, which I would recommend doing so that you're actually reading it and not just clickety click, 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 clickety click, click, click. Because when you get to the back side, you're going to be like, oh, I guess I didn't read that very closely. So go through, actually read, actually go through and click so things show up in the right order. There's a quick video on solutes versus solvents. Okay, so for this video, it does go on for quite a while. At least watch it through the first part of the course, though. And then this very last one, okay, I will tell you, I don't know why she stirs the mixture with the back end of the spoon. I also am not sure why there are like stuffed animals there, but these are really good. It's got a really good example of how we can separate things. So that's why it's there for that. And then getting started on the back side, because this is where you're going to put into use what you've just learned. So on the back, we're looking at what is a solute versus what is a solvent. The way to remember these is remember solute literally has less letters. It's what we have less of. Solvent has more letters, so we're going to have more of. And it's got the little less and more here. Just kind of an emphasis. That's how to remember it. Solute has less letters, so it's what we have less of. Solvent, it's what we have more of, and it's going to do the dissolving. So let's look at one of these examples. And all the things that go up here are down here. Actually, we'll do 2 of them because there's one that kind of gives people some grief. So salt water. If I'm going to make salt water, it kind of tells you what the 2 things are. Salt and water. Whoa! I know, you totally didn't see that one coming. So in salt water, what am I going to have more of? I'm going to have more water, because if I have more salt, it's going to be a super thick, not able to move around solution. So I'm going to have more water if it's salt water, and I'm going to have less salt because the salt is dissolved in the water. One that sometimes is a little bit tricky is air, and it's not on here to be problematic, but I can see where some people get a little tripped up. Air is actually mostly nitrogen. The air we are breathing right now is actually mostly filled with nitrogen. And then there are other gases like oxygen, which we need, carbon dioxide, water, methane, There's lots of other things that are dissolved, greenhouse gases, methane. So this is what we have less of in our air. So you need to then fill in those last bits. So we did one of the waters, one of the salt, and we did the oxygen, carbon dioxide, etc., and nitrogen. Finish this part up. And then on the bottom here, this one, it's not meant to be tricky, but sometimes people are like, I don't get where to start. We've got a word bank at the bottom and we just need to fill it all in. So the big thing, our big topic, if you look on the front, are our types of mixtures. Then if you look, we've got it broken down into two big parts, three smaller parts after that. And then there are examples within it. So this backside is kind of just wrapping up what we learned. So our big thing though is we have mixtures. And then we said we've got two different types of homogeneous mixtures and one type of heterogeneous mixture. So finish that then. And we've got those three. And now you can continue. You're going to have multiple things that go into these boxes on the bottom, and that's totally okay. This one for homogeneous, it really doesn't matter which item you put, like which set of things you put in which one, just that they're all together. I'm going to leave you there. You have the rest of this time to be finishing up and working on this. As always, please let your science teacher know if you have any questions. And if you've made it this far, you're still like, wait, should I do this online or paper copy? Paper copy is going to be the best. Please make a paper copy if at all possible, whether that means rewriting it or if you've got access to a printer or you have it from class, the paper copy is going to be the best. Have a great day, everyone. Bye.